Hi everyone, it's Nate and welcome back to Elevate with Nate, the place where we're all about learning, self-improvement and motivation, where I discuss something new that I've learned in the last 24 hours, and I encourage you guys to all, in the comments, tell me what you've learned in the last 24 hours, what you've improved on. In today's episode, I'll be discussing something called edge computing. Now, before I start talking about this, I'll mention briefly cloud computing, which I presume probably most of you might know a bit about. But essentially, this is where the data processing happens in a centralized warehouse across the world. And if you have been following my channel now for a while, you might have watched the episode I made on Wi-Fi and the internet, where I discussed this in a lot more detail. But essentially, I talked about how if you, let's say in your house using the Wi-Fi, want to search for something on your phone, what will happen is to get that data using the modem, the router in your house, then potentially the internet cables across the world under the sea potentially, that will link up this data. But it has to be sent across and then come back to your local area network and then to your device. Whereas similarly for 4G or 5G, we talked about how the data will be sent to the cell tower, so essentially the antennas, and from there it's a similar path. So that is cloud computing. But what is there for edge computing? And this is something different where instead of all the data processing happening far away in a centralized area, in this one it happens a lot closer to home. So, edge computing, what is this and how does it work? Let's start off with, therefore, the edge devices. And edge devices essentially will be things such as sensors, cameras, or any other IoT devices which can generate data. And in case, again, you're wondering, what does IoT mean? This just means Internet of Things, which refers to any device which, say, will have, say, sensors or the software which can communicate and exchange data between other devices or systems. So any of these things can be edge devices. And these edge devices will often have on board processing units such as CPU, GPUs, TPUs. Again, I have done an episode only recently on GPUs, that's graphics processing units. So watch that if you're not certain what that means. But just quickly, CPU is the central processing unit, the main brain of the system, and TPU stands for tensor processing unit. So what this can do is it can do AI inference, data analysis, image processing, any of these things. So the software algorithms from these units can therefore be used to process the data collected from the sensors. Here though is the fascinating, most important bit, which is this can be done in almost real time because it's so localized. There's no large distances, whereas such as with cloud computing, which there will be. So this could be, for example, using, let's say, smart devices like a thermostat, which can immediately change the temperature. Or there could be surveillance cameras, which can immediately alert authorities if something suspicious has happened. Right there and then it can process this. And on top of that, some of these devices will be able to store the data locally, or even show it on, let's say, a screen. These are all things that can be done. But also what's quite nice is if the data which is being produced isn't needed right there and then, it isn't imperative to access it immediately, then they can also have a hybrid system where they'll then send off parts of the data to the cloud services. So that still can be happening as a second action. So as you can see, there is the cloud computing and the edge computing much closer to home. But there is also going to be a situation where you have a kind of a middle ground. And that is, not all the edge devices will have the sufficient processing power to get the job done, which it has to do. In these scenarios, there's something called fog computing. And this essentially is an intermediary layer between the cloud sensor and your edge device. And an example of this could be what they call an edge gateway. So the data will be sent from your edge device to this gateway. And here they'll have a lot more powerful systems in place which can deal with the data and action it. But it's still a lot closer than if you're sending it to the original centralized cloud bases. Hopefully this is making a bit of sense. But like many things, I'll give you some examples right now of this in real life. So here's an example, which would be including the fog computing, which would be smart traffic. The edge device would be the cameras and the sensors. The fog node might be placed in an important part for traffic. So it could be an intersection. So that's where you have all the actual more powerful machines to process the data. And then finally, what would happen there is they'll be sending off the data, which I don't need right there and then, which could be used for long-term storage or to predict future congestion or to simply optimization. And that data is sent off to the cloud. So hopefully you can see, because that's predicting the future, that isn't required right there and then, hence why it makes sense to use the cloud. And hopefully what you're noticing here is that one of the most important uses for the edge computing is scenarios where you need to have very low latency. So latency again means simply kind of how quick essentially you get the data which you need to use. So in those scenarios, this is very, very useful. So let's talk about, just very briefly, the pros of using edge as opposed to using the cloud computing. And there's a few obvious ones here. One will be, again, if you require low latency. A second would be you need some low bandwidth. Other benefits also include if you're in a location geographically that has intermittent internet connection. In those scenarios, you can still use the edge computing, but of course the cloud it won't work. So that is a pretty massive plus for the edge computing. And then finally, there's the thing about the simply security. If you're sending off your data constantly across networks, there's always a chance that some hackers might be able to hack into that. Whereas if you're keeping it all in this kind of local network, there's probably a lower chance of that happening. So those are 4 important points as to why edge computing is used and why it's useful. So as the last thing for this video, I thought I'd mention some more examples of situations where things use the edge computing, ones which definitely don't use edge computing, and other scenarios which can use both. So here are some examples for edge computing. Self-driven cars. So imagine right now you're in the car and then there's an obstacle or has to do a quick turn to the left or whatever. That is imperative in those scenarios that you have the low latency. Imagine right now if suddenly someone jumps out front of the car and then your computer has to, or the system has to go, right, send it off all the way to the cloud to retrieve it, bam, you've already hit the person or the object. Has to be low latency. Or even imagine, oh sorry, there's no 4G in this area. Okay, that's not going to be at all handy. Self-driven cars. Other ones might include AR/ or VR headsets. That there again, you want to almost immediately have this thing given the inputs and outputs that it requires. So that's an example. And then another very important one will be actually for healthcare instruments. So think about some health monitors. Let's say for example, it might be checking your heart rate. That might, by the way, not be the exact use of it, but in health. That needs to be, again, very low latency. If something's gone wrong, and let's say in my example, they can tell that the heart rate beat's going to almost zero, something's very bad happening, it needs to immediately alert the people in the hospital. So if you're again using the cloud system and the Wi-Fi happens to go down, well then I wouldn't work with it. So these are very crucial implementations of edge computing. So on the flip side, here are two examples of when things don't use it and use the cloud computing. So firstly, as I mentioned at the very start of this episode, if you're simply on your phone browsing or on a laptop, that there is not imperative you get it immediately. That will use the cloud computing. Or other examples such as streaming services, Netflix, YouTube. Now, Netflix and YouTube actually do use something called content delivery networks, which essentially I think they're a bit similar to the fog networks, which bring everything kind of closer. But still, majority of the data will be stored on the cloud far away. And then finally, systems which you will be aware of or use personally, which use both. So going back to that example earlier about the security cameras, well, a non-edge, say the cloud computing, might be simply sending back all the footage to be stored for future use if need be. That's in the cloud. Whereas for edge computing, it might be motion detection, facial recognition. All of those things will be done, again, by a GPU somewhere, locally, but that will be, of course, edge computing. And then that, if there's an issue, will alert the authorities. That has to be right there and then, edge computing. And a second one might be, I forget what it's called now, is it the Amazon, let me check, Amazon Echo, okay, which people have in their houses. A non-edge example, so a cloud example, would be, you say, please tell me about this topic, or whatever it is that Amazon Echo does. I'm imagining Siri here. But that will, of course, have to send information into the cloud and back. Whereas if, for example, you say, please make that light go green on your device, well, that doesn't have to go back to the server. That can happen right there and then. So that's an example there of scenarios where you have edge and cloud in the same system. So just remember the main four things for edge computing and why it's useful. It's when you want low latency, when bandwidth is a limiting factor and you need low bandwidth, for security reasons, and then finally, if you cannot deal with intermittent connectivity to the internet. In those four scenarios, edge computing is the real deal. I hope you all enjoyed this episode. If you did, please give it a like, and if you haven't already, please subscribe to this channel, to Elevate with Nate. As ever, let me know what you've learned in the last 24 hours. It's a community of improving. It's Nate, it's been great, onwards and upwards.